Today, I want to discuss some problems related to chapter number 7. So, this problem is 7.10. A square loop of side A. This is a square loop. Each side is A, is mounted on a vertical shape. It is mounted in a vertical shape. It can rotate and rotate at angular velocity omega. It can rotate with angular velocity omega. A uniform magnetic field B, this is a uniform magnetic field, has been applied from the left side, points to the right. Find E of T for this alternating current generator. When we place this square in a magnetic field, then it can rotate with some angular velocity omega, then a current will be generated. If a current and EMF is generated, then find this EMF. How is it possible? How we can find out? We know from the we need to find E of T, and this is possible when we use the Faraday's law. And Faraday's law states that EMF, which is equal to minus d phi divided by dt. This is equation number first. And this equation we need to find out flux, and we know the flux is related to magnetic field, the dot product of magnetic field and area. Here the area of this loop is length into width. So length and width are equal, it is A. Then area, which is equal to A into A, which is equal to A square. So this is the area of this loop. This loop also makes an angle theta with magnetic field. This also makes an angle theta. It means that when it is rotating, then there's some angular displacement appear, and this angular displacement is related to the angular velocity. This angular displacement is equal to omega t, or we can also say that angular velocity, which is equal to rate of change of angular displacement. So this is angular velocity. So the dot product we can have cosine theta, and putting the value of A, which is equal to A square, the area of this loop, and cosine of theta, and theta is equal to omega t. So this is the relation. We must put the value of phi in equation number first. We have b a square cosine omega t. This is a just differentiation with respect to time. So cosine theta minus sine omega t and omega. And then final form of this EMF is equal to b a square omega sine omega t. So it is time dependent. So this is the required result. Next, the problem is 7.11 and it states that a square loop is cut out of a thick sheet of aluminum. This is a loop which is cut off a thick sheet of aluminum. It is then placed so that the top portion is in the uniform magnetic field B. This shaded area you see here, this shaded area denotes the magnetic field which is inside this board, and this aluminum sheet which is in the square form, and some portion of this is in the magnetic field and some is outside this magnetic field, and allowed to fall under gravity, and this whole system is allowed to fall under the action of gravity. In the diagram, shading indicates the field region B points into the page. I have already discussed this point. If the magnetic field is 1 Tesla, if this magnetic field is 1 Tesla, find the terminal velocity of the loop in meter per second. What will be the terminal velocity of this loop? And then find the velocity of the loop as a function of time. The second point is the velocity is a function of time. And the third point is how long does it take to reach, say, 90% of the terminal velocity. This we need to find out the terminal velocity initially, and we know whenever the EMF is produced in a loop, then it must have BLV. This is the relation between EMF, and when a loop is moving with velocity V and it has some length L, then it must be equal to this. And this EMF, which is equal to IR, and IR, then I is equal to BLV divided by R. Then the force acting on the loop is, this is the current, then what will be the force acting on this loop? And we know from the this expression that F is equal to ILB. We already know about I, that I already calculated, then putting the value here, and we will get B square L square V divided by R. And this force is upward. This force is in the upward direction, and the gravitational force is in the downward direction. Then we must write down the equation of motion. What will be the equation of motion? Mg downward, and the force, the magnetic force, is in the upward direction, but as a whole, the system is moving down with some velocity v, then it must have some force. The total force must be F is equal to ma. So mg minus b square L square v divided by r, which is equal to mdv divided by, this is the acceleration. And from this equation, we can find out dv divided by dt, which is equal to g minus bl square mr. For simplification, let's consider b square L square divided by mr. This is, for simplification, it is equal to a. Then this equation dv divided by dt, which is equal to g minus a v, and this is equation number a. And from this equation, we need to find out v in terms of t. How is it possible? Then dv divided by g minus av, which is equal to dt. And then we must integrate this, and after integration, from this equation, the integration of this term, which is a natural log of this thing, and the log of this log of g minus av, and the minus 1 over a, which is equal to t plus constant of integration. Then minus 1 over a log of g minus a v, which is equal to t plus c. And we must find out this constant of integration. What will be the value of this constant of integration? To find this, we put the initial condition. The initial condition is when time is equal to 0, then the velocity is equal to 0. The value t is equal to 0, then v is equal to 0, then it means that we can have the value of c. The value of c will be equal to minus 1 over a log of g. Now putting the value of c here, then minus 1 over a log of g minus av, which is equal to t minus 1 over a log of g, and then uh, minus 1 over a log of g minus a, here v as well, plus 1 over a log of g, which is equal to t, and we can take 1 over a common, and after taking common, we may write down this as log of g minus log of g minus av, which is equal to t. And by the rules of logarithm, this 1 over a, this must have log of g minus av, sorry, g minus av, which is equal to t, and log of g divided by g minus av, which is equal to a t, and after eliminating the log from this side, then g divided by g minus av, which is equal to exponential of at. And if we reverse this, g minus av divided by g, which is equal to e to the power minus at. This is a straightforward mathematics, and then this must have the form g minus av, which is equal to g e to the power minus at, and if you find out v, then av, which is equal to g minus g e to the power minus at, and v, which is equal to g divided by a, 1 minus e to the power minus at. And further, if I write down this is in equation number 2, we call this equation as, and I label this as an equation A. It should be noted that at terminal velocity, the acceleration goes to 0. Terminal velocity, it is the maximum velocity when a body is moving from some height and it attains a maximum velocity. Then at the maximum velocity, the acceleration, the velocity remains constant and the acceleration goes to 0. Then we can say that the terminal velocity, the acceleration goes to 0. Then using equation A, using this equation A, for the terminal velocity, then the left hand side dv divided by dt is equal to 0 and g minus av, and then av, which is equal to g, and v, this is actually the terminal velocity, vt, which is equal to g divided by a. And putting the value of a, which we have calculated, we have supposed the value of a, and it is b square l square divided by mr, in g b square l square divided by mr, and vt, which is equal to mr, g divided by b square L square. So this is the terminal velocity, but we must find this in term of in meter per second. We must know about the mass of this loop, the resistance of this loop, and uh, what is mass and what is R. Then mass, if we define density, mass per unit volume. And what is the volume of this loop? The volume of this is area into length. Area into length, this is also called a volume. But here, this is only for a single this line, for a this which has length L. But here we have four lengths, 1, 2, 3, and 4. Then the density must have the form m divided by 4al. So this is the complete density. And if we find the m, then m will be equal to 4al and eta. Eta is the density. And we can also find out the resistance R. R, this is the resistivity, which is uh, the resistivity, and the length as directly related to the resistance. Here there are four lengths, then we multiply this by 4, and also area, which is area of this loop, because if we increase the area, the resistance decreases, and if we increase the length, then this will increase. So R we can find in this way. Now we have all these things, mass and R. Putting the value of R and M in this equation, this terminal equation. Let's say this equation is equation number 3. And then I want to remove something, but let's say if I complete this Vt, which is equal to m is equal to 4 area L and eta, and R, we know R is equal to 4 L rho divided by area, and G divided by B square and L square. What the things that we can cancel out? Area and area, and then L square with this L square, and finally the terminal velocity will have the form 16, 4, 4, 16, and eta and rho G divided by B square. Now, what is density? What is rho and what is G? If we put all these values in this equation, then we must reach to to calculate the terminal velocity. Here, rho, the density for this is, if I write down here, here density This is given for this system 2.8 into 10 to the power minus 8, 2.8 into 10 to the power minus 8 ohm meter. And G, we know the value of G, 9.8 meter per second square. And what is eta? This is the density. And density for this system is 2.7 into 10 to the power 3, 2.7 into 10 to the power 3 kg meter per second cube. Kg per meter cube, sorry, kg per meter cube. And B, already given 1 Tesla in equation. This is 1 Tesla. Putting all these values, then the terminal velocity must have the form as 1.2 centimeter per second. You must check this. You must check this and calculate the terminal velocity. Okay. Now, the second question, which is a function v as a function of time. If you look this equation, v, which is equal to g divided by a. This g divided by a, we already calculated this g divided by a. G divided by a, this is the terminal velocity. Putting here, then v, which is equal to vt and 1 minus e to the power minus at. So this is the velocity, which is a function of time. So this is the second part. The first part is this, and this is the second part, which is a function of time. Now the third part is find the time when the terminal velocity reached to the 90%. 90% of terminal velocity. Then how is it possible and how we can calculate this? It means that V, which is equal to 90% of Vt. This is the statement indicates that V is equal to 90% of Vt. And if the 90% means 90 divided by 100 Vt, and this is 0.9 Vt. It means that V is equal to 0.9 Vt. And last, in second part, we have calculated V, which is equal to Vt and 1 minus e to the power minus at. Already we have calculated. Then from this statement, V is equal to 0.9 Vt, putting this 0.9 Vt, which is equal to Vt and 1 minus e to the power minus at. This Vt cancel with this, and 0.9, which is equal to 1 minus e to the power minus at, and then e to the power minus at, which is equal to 1 minus 0.9. And it means that this is equal to 0.1. We need t. Then how we can find t? Then take the log of this. If we take the log, then minus a t, which is equal to log of 0.1, and t, which is equal to minus 1 over a, log of 0.1. From this equation, minus 1 over a and log of 1 divided by 10. We can write down 0.1, which is equal to 1 divided by 10, and then minus 1 over a, and we can also write log of 1 minus log of 10. Then if we take minus common, then t, which is equal to 1 over a and log of 10 minus log of 1. And log of 1, which is equal to 0, then equal to 0, then t, which is equal to 1 over a and log of 10. And we also know the value of a. We also know the value of a is a, which is equal to g divided by vt. Vt is equal to g divided by a. We already calculated this. Then a, which is equal to g divided by vt. Then putting the value of a, then this t, which is equal to g vt divided by g log of 10. T, which is equal to vg vt divided by g, and this. So this time is when the 90% of terminal velocity. This is the time, required time. The problem number 7.12 states that a long solenoid of radius a, this is a long solenoid which has a radius a, is driven by alternating current so that the field inside the solenoid B is equal to B naught cos omega t. Find the current in a circular loop of wire of radius a divided by 2. At the requirement of this problem is to find the current in a loop which has a radius a divided by 2. So we should focus on this circle which has radius a divided by 2, and we must find the current in this loop. So I of t, which is equal to we need, and the requirement is to find I. And we know by definition I is equal to, from Ohm's law, E divided by R, because EMF is generated here. And from this equation, if we see here, then we need to find E, and how we will use the Faraday's law. E is equal to minus d phi divided by dt. Then in this, if we have to find out E, we must know about phi, this flux. Here phi is unknown, then the flux through the loop that has radius a divided by 2 and resistance R. Then flux, which is equal to B dot A, and B we know from the statement it is equal to B naught cos omega t, and A, what is the area of this loop, this small loop which has radius a divided by 2. Area for the circle is pi r square, but here the area is a divided by the radius a divided by 2, then pi a square divided by 4. This is the area of this small loop. This circle has area pi a4 divided by 4. Putting the area, and then after some simplification we can find out the flux. This is the flux, and then put the value of flux in equation number 2. Equation 2 implies minus d phi divided by dt. Flux, just we must differentiate. This becomes minus sine omega t and omega. So this is just a simple differentiation, and we can get here. And if we have E, then we must put all these things in equation number first. Then if we put here, then this is the final result, I of t, which is equal to this thing. Problem number 7.13 states that a square loop of wire with side of length A, we have a square loop of wire with side of length A lies in the first quadrant of the xy plane with one corner at the origin. In this region, there is a uniform time-dependent magnetic field that is given B of yt, which is equal to ky cube t square z. K is any constant, and find the EMF. This is very simple, because we should find E, and E is equal to, from Faraday's law, minus d phi divided by dt, and from this equation we need phi. And how to calculate phi? Phi is equal to integration of b dot dA, because this is a square loop which is in the xy plane. Then we have the magnetic field ky cube t square, z as the direction of this magnetic field, and area we have xy plane. Then length into width, which is equal to, this is the length and this is the width, dx and dy. So this becomes an area, and the direction of this area is a. Then a and this z will z dot a, which is equal to 1. And then kt cube, this is a common, and we must integrate this from 0 to a. From 0 to a dx, we can write this separately, dx and dy. So 0 to a dx, 0 to a y cube dy. From this integration we can get a, and from this integration y 4 divided by 4, and from 0 to a, and putting all the limits, then y 5, because a1a is this one, and ya 4, then this becomes a5, and 5, which is equal to 1 over 4 kt square a5, and putting the value of this phi in equation number first and just differentiate, one can get a very simple expression, minus half kt a5.